Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 6.1.2. Changing our view with post isomorphisms. Okay, so what we're going to do is we're going to start with a vector space that's spanned by two vectors. And how do you know that this is really like a minimal set, right? In fact, in this case, we know it's not because this is like a multiple of that. But how can we change this readily? Do we have kind of a procedural technique that can change like a set of vectors to like a minimal set of spanning vectors so we can kind of see what the degree of freedom is of the vector space or what its isomorphic dimension is, like, in terms of after relabeling it, is it like, can it be relabeled as like two tuples, one tuples, three tuples, four tuples? Um, and that kind of free structure is actually important in different types of applications in seeing how things isomorphically relate. So that's what this little subsection helps us talk about. All right. So, all right, we're going to talk a little bit about some isomorphisms, which preserve structure and are bijective and preserve the notion of tupleness or dimensions. All right. So what we're going to do is we're going to take a set of vectors and apply these operations to them until it becomes more clear if what the minimal set should be. So we're going to do this kind of in a very simple way. So first we talk about certain types of isomorphisms that we can do. And that's kind of what this discussion goes through right here. Essentially, all right, so we have an isomorphism like this. You can take ABC and you can subtract off, let's see here. Okay, so if we look at this, ABC is equal to this. This is just another way of writing it, where these are standard basis elements. This is like 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and you kind of outside multiply and add, you should get this. Okay, so let's see what happens to ABC. Okay, what happens if we replace E2 with E2 plus 3E1? I guess that's the idea. What happens if you just replace this with that? Does that produce an isomorphism? And this goes through and actually shows, let's see, it simplifies the map and shows that it looks this is another way of representing it, and it also shows that it does indeed have an inverse. It's invertible, which means it's an isomorphism. It's bijective. Um, okay, so there's different things that we can do. We can add in one of the entries kind of a multiple of another entry. So you take one entry and add a multiple of another entry. That is a viable isomorphism. Other isomorphisms are like switching elements and maybe multiplying multiplying one of the elements by something and so forth. We can actually view these as vector space operations. So let's suppose that we have three vectors, all right? So, okay, so the vectors are, so let's say we have three vectors and we're going to line them up in columns. So the first row actually represents all the first entries. So, just like here, we were like replacing, so we're replacing the first entry with itself minus a multiple of another entry. That's kind of like replacing a row by itself added to a multiple of another row. And we're doing, because what we're doing is we're applying the isomorphism to all three vectors at the exact same time. All right, so we're putting all three vectors into this isomorphism at the same time and seeing what the results are. This is called an elementary row operation, when we have the columns being the vectors. So This is a little description of how you can do that. But basically what we're doing here in this case, the outcome of this is simply we've replaced this middle guy, let's see, by itself, and then -2 times the top guy right here. And so if we did that, it's kind of like taking this top guy, multiplying it by 2 and sending it down here. We can, let's see, so we take this top row and we multiply it by -2 in the air. Okay, that's kind of like in the air. And then we send it down and plop it right here, drop it on this right here, and add them, and we get something like this. So what we've actually done is we've actually applied an isomorphism to these set of vectors, and now we can view this in another way. All right, and so that's called an elementary row operation. Okay. So these are a description of what we can do with an elementary row operation. Each one of these is like an isomorphism, and we can do simultaneously to a set of vectors written as columns. Okay, so if we can apply these row operations in such a way that first we try to get the first column looking like, so we're kind of, it's like relabeling, right? So these are isomorphisms. Isomorphisms are bijections that are just relabeling. So we want to relabel this first vector via these isomorphisms as like E1 itself, like 1, 0, 0. That would be nice. So we first try to relabel this like this using these operations, and going on, then we try to relabel the next one as E2, 0, 1, 0 via these isomorphisms. And then in the end, hopefully we can you know, if we can, we can relabel this as 0, 0, 1. In this case, you actually can't at all. It doesn't relabel that way. There's no possible way to do that with row operations. Key to relabeling the first guy as 1, 0, 0 is to have a 1 right here. If you didn't have a 1 right here, then you do some kind of row operation to get a 1. Then you can use that 1 kind of as a key player that comes in and multiplies by something and then kind of plops on the other guys down below it to clear it out to zeros. And then after you do that, you get a 1 in this position right here in the middle, and use that guy to play against the guys above and below it in order to get what you want right here via these row operations. Okay. So we noticed that in the end, in the relabeling, these two guys were relabeled like a Z1 and E2, but this guy, it's just actually, it relabels at the moment as this, which notice, this is actually in the span. This is like multiple of, that's like a multiple of this plus a multiple of that. So it's like a tag along. So in other words, it doesn't need to be included. It's too much. It's not in the minimal set, which means that really after relabeling, you only need 2 guys in order to span everything, which means the dimension, say, is, or the measure of freeness is actually 2 for those, for the span of those set of 3 vectors that we started with. Okay, now, right, okay, so in the next section right here in section 6.1.3, we'll actually see how we can do some more types of operations past what we've done here to actually even simplify the picture even more. So what we've just done is we've just done what we call post-isomorphisms. So isomorphisms on everything that we see, like, and we apply them to them, and then we apply isomorphisms after, on top of that, and then on top of that, and then on top of that, in a composition kind of going out this way. So that's in the next section might be clear why we call that post-isomorphisms, because we're going to deal with something called pre-isomorphisms. Post-isomorphisms were just row operations. Thanks for watching.